A very warm welcome to everybody joining us in today's Ekahau webinar series. There's a bit of crowd control going on here. We might be rocking out. Who knows? We'll find out soon. Today, we're going to be covering how you can cover your large public venues and the help you can get from using external antennas. There's going to be great best practices in this webinar, use cases, real practical examples of how you can use external antennas to focus that energy at certain parts of your large public venues to create that coverage that you need and also potentially some capacity. Not only that, but Connor is an expert in hiding access points and antennas. So we might have a few challenges for you in the show later on, see if you can spot some of the cool ways that they've been able to blend in some of these access points and antennas into the environment. So without further ado, Mac, why don't you do a quick round of formal introductions for us?
Of course, of course. So guys, typical crowds here. Matt and I, directors of ECSE and product marketing, joined by Dale now, SE, and Stu will join probably later because he's like at the airport or somewhere like traveling. So he'll probably sit in the toilet and join us from there to help with Q&A. But the biggest start of the show today is Connor. So Connor, welcome. Thank you very much for joining today. We are super excited to have you. It's always great to have you, and we are looking forward to your stories and your examples. Can you quickly introduce yourself before we dive in?
Yeah, again, thanks guys for having me on. It's always a blast doing these webinars with y'all. I'm Connor Burke from Excel Tech Solutions. I'm our antenna product manager and engineer, so I oversee all the development, best practices, design, utilization for our antennas. We've done a lot of stadiums and large public venues as of late, so we feel like we have a pretty good understanding and expertise in this area. So it's always great to come out here and share that with y'all. So hopefully I can give y'all some knowledge.
Sounds great. Thank you so much, Connor. And Mac, you said typical crew here, but it's not been a typical crew for a while because you've not been here. So we've missed you, and welcome back to the webinars. Two without you. I don't know how we
might have missed two webinars, I think.
Yeah, I don't know how we've coped without you, but I'm sure everyone is glad to see you back, just like I am.
Yeah, I'm sure that without me it wasn't that dirty.
Yeah, it was quite clean for once. But anyway, Connor, over to you, and then we can get started with your part of the presentation.
Yeah. So we're going to talk about large public venues, and that can mean a multitude of things. So when we say large public venue, we can either be talking about stadiums and arenas, and we'll go into kind of the differences and some of the subcategories of that in a moment. Large convention centers where we host like Cisco Live, Aruba Atmosphere, those events, or auditoriums. All those kind of have their different design challenges that we'll go into and the best practices that you can use to overcome those challenges. But starting off, we're going to look at stadiums and arenas. So within stadiums and arenas, there's a couple subcategories, those being either open air or enclosed. So open air is typically a football or a soccer arena, and enclosed is more hockey, basketball, or concert venue. So those have different needs and different mounting options and design necessities, but we'll look at specifically at the start open air solutions. But before we get to that, I want to do a quick poll question, and if Matt, you can bring this up. Just what is the necessity that y'all have for aesthetics? How much does that matter in your deployment? I'm curious to see y'all's answer here.
Oh, I'm just glad I picked the right poll question. We got a few coming up today, and we was talking about poll questions between Connor and myself, and we sent over a few, and then Connor decided to flip the way we're going to answer these poll questions. I think really just try and catch me out to see if I can launch them in the correct order. So let's one out of three done right so far, but we'll give it a few more moments.
You didn't have too much time to prepare because normally I read the questions including the answers, so we're from under the bus.
Yeah, they definitely put me to the test today. But I can see that there's been a great participation on the voting for the poll question. So I'll just give it a couple more seconds and then I'll end the poll and I'll let you talk through the results, Connor, and share those results. And we should be able to see that now.
Okay, so pretty overwhelming on the somewhat, yeah.
But it's not just somewhat, it's a somewhat and large portion. So these are 8 results for AxleTech, aren't they?
Oh yeah. So what we see a lot of the times is in these environments for large public venue, they're very public facing. So having very high aesthetic requirements is very common. The architects will come in and immediately slash something down if you put a big white antenna or a big white eyepiece on their ceiling or on their wall. they do not approve of that. So getting them involved very early on to be able to approve what you're going to do is always important. So keep that in mind as you go through the design of any large public venues, is get them involved so that you don't have to go back and redesign everything after the fact because they didn't like the aesthetic of it.
What are some of the kind of options that you can offer to solve those solutions, Connor?
Yeah, so there's a bunch of different options. We'll look at some specific use cases a little bit later on, but there's either getting it out of view, so whether that's mounting it farther away and using a more directional external antenna, putting it under the seat, which we'll go into next here, or hiding it with some variant of a cover or a skinned cover so that it blends into the environment and it just disappears from the eye of the average consumer. So there's a bunch of different options, and it really just depends on what your needs are and how you're going to go in and design.
Awesome. Right.
So as we mentioned, the different options, so there's typically 3 different styles of design methodologies that you'll see in a stadium or arena, that being underseat, overhead, or handrail design. All these have benefits and detriments that we'll get into, but starting off, we'll look at underseat. And a point of note here is that when you're going through these design options and really picking which one works best for you and your environment, try to stick with one. You can kind of mix the methodologies, but it's not recommended. That biggest problem would be where your clients roam to. So the best example here is if you do a mix of underseat and overhead, well, as you have people come in and they come sit down, they may associate to that underseat AP. They may come in and be, okay, I'm hearing that underseat AP with the best RSSI. I'm going to associate to that one. But as more and more people come in and they attenuate the signal more, and that person gets up and leaves to go get a snack and then comes back, well, they may not go back to that underseat AP. They may roam to the overhead AP and stay on that one. And even if people leave and they hear that underseat AP with a higher RSSI value, it may not be high enough for it to roam back to the underseat. So you're going to overload all the overhead APs. And the same goes if you were to mix underseat and handrail or handrail and overhead. So it can cause issues with where your clients roam to and if they get sticky to one or the other. So if you're designing a section, keep it to one methodology. Now you can mix that up between different sections or different areas, but within a single area, try to stick with one. So looking at underseat specifically, there's a bunch of different options that we actually offer, and there's a couple others out there on the market to do underseat deployments. The biggest benefit of these is that they're great for open air solutions because the attenuation from the bodies actually prevents the signal from being heard from the opposite sides or from the other corners. So you're not going to have to worry about channel reutilization as much because there's nothing for it to really reflect off of and make it to that other side. But the issues that you're going to see are it's very dependent based off of the actual capacity that you're having, how many people are attending your event. So your coverage will change as you have 100% attendance to 75% attendance to 50% attendance. And we kind of talked about that a second ago with where your clients roam to as people come in and come out. That can cause challenges. So you have to deploy that a little bit differently and a little bit more just with intuition than you would for an overhead deployment or a handrail deployment. It is easier to be able to maintain though, because it is on the ground now. So instead of having to go out onto the catwalk or get a scissor lift or anything like that, you have easy access to those devices. You can either just use safety torque screws like you see there for the bottom ones, or this top one here just has a drawer that slides out to be able to access the AP. So they're much easier to do any maintenance if you have to go in and reset an AP or swap out APs for future deployments. And their aesthetics are very nice as well. Most people aren't seeing these under the seat. Maybe that one person who gets that specific seat assigned to them is seeing it, but it's typically not going to be a very open to the eye kind of deployment. The biggest issue that we see with underseat deployments is that every single stadium has a different type of seating. They aren't standardized to where there's 2 feet of clearance and you can go out 8 inches to be able to make sure that it's not extending too far, or the seat can still fold down. So it has to be a really customized solution for the majority of these stadiums to be able to fit under there most optimally. So that's the biggest thing we do is doing custom solutions for underseat deployments. We have a ton of variants of these now, but it is very custom. And looking at a design methodology here, though, is for underseat, we recommend trying to match the grade of the stadium. So if you have a 30-degree slope on your actual stadium seating, you want to put that AP at that 30-degree slope. Now, most stadiums sit somewhere between 20 and 30. You won't see typically higher than that just because that's a pretty steep grade and it's hard for people to climb. So it's relatively low angle and it's easy to get an AP in there. But you may be thinking, well, how can I design my actual stadium seating here if I have it at a slope and there's a slope for the actual stadium? Well, at this point, we kind of have to think about what's your reference point. So yes, you could think about, oh, well, I can't really design at an angle right now in Ekahau, but if we look at it and we're matching the same grade, well, all you have to do then is rotate your thinking, and now you're on a flat surface and the APs are flat to the ground. So it becomes much simpler in that thinking now, and you can go in and design like you would regularly. So instead of having to be concerned about that, you can go in and say, okay, well, I have my underseat enclosure, the AP is flat gradient, and now I can just pop them where I need them to be able to have that coverage. And in these cases, if you're just using the internal APs, most APs that are out there right now on the market have what's called a down tilt. So instead of having a perfect omnidirectional antenna to where you can imagine a donut of coverage, it's actually focused forward to the face of the AP a little bit. And in these deployments, that actually helps you. It gets through those bodies that are physically sitting on top of the underseat enclosure better. So you're not having to worry about, oh, okay, well, most of my signal is being attenuated right now, and I'm having to deploy a ton more APs in this area. That down tilt is beneficial both in a normal deployment on a ceiling as well as under the seat. But sometimes using the internal antennas isn't always an option, or you need a ruggedized AP, or you just don't want to have the AP anywhere near where the people are going to be sitting because everybody cheers and shakes their beer and spills it around, and you don't even want to risk your APs getting damaged. So in those cases, you could look at using an enclosure with just some dipole antennas. This is a larger one, but you can use dipole antennas to achieve the same thing, to where it is that donut coverage, but it is a higher gain than the typical AP. And in these cases, a lot of times you can use a ruggedized AP, so you really don't have to worry about it getting damaged if anything were to fail on a seal. So like this here is the Aruba 518, and it's a weatherized AP, and it's very secure, and you don't have to worry about it in that case. Or you can go and look at it as, okay, well, I need my AP completely out of the way, and I need a really small footprint because I'm just using bleacher seating. There's no folding out seats. Well, in that case, you can use just a really small 6x6x2 enclosure that holds those little dipole antennas, and you just mount that to the back part of the seat. And this is a lot lower profile. It keeps the APs away. It's very easy to swap in and out. So it really just depends on what your needs are for the underseat deployment. But we can kind of look here and see that roughly your coverage is going to be the same between all these options, and you can still kind of keep the same capacity or coverage requirements that you need. So in this case, these ones right here are utilizing the little stubby antennas, like in that 518 model, just flush mounted on the ground with the underseat enclosure. And even if you swap that and do just the little wall box that has the 6 antennas, you're going to achieve roughly the same coverage. But you can see here that it has that more donut-shaped horizontal coverage comparatively to just the AP being flat. And then again, if you just want to stick with using a standard internal AP, if it's an indoor stadium, if you have a very good enclosure that's not going to be having any seal issues, all these are great options, and all of these will provide you with roughly the same coverage. It really just comes down to personal choice, aesthetic choice, and what you need in your environment.
So it's a great demo, Connor, but I think maybe why don't we this is going to be a really good question, especially for like what you're about to talk about now, the overhead stuff. But Daniel asked a really good question in the Q&A around when using sector antennas with their access points. They use them to have less interference, but the clients usually have regular dipole antenna pattern and are going to interfere with our clients in the stadium. So clients have kind of a lot of interference, and listen before talk limits their throughput. Or is he completely off topic?
No, yeah. So in these environments, and we'll kind of get into that a little bit on the overhead design specifically, the client noise is actually one of the biggest issues. So even if you have a very sectorized antenna that's 20 by 20, or even narrower in some cases, it still is going to have those side lobes. And in these environments, you're not high enough for those side lobes not to be able to hear the adjacent client. So yes, having the dipole of a client being in the environment, it's going to cause some problems for the actual APs that's associating to, and it will cause some issues. So that's where doing underseat can actually kind of help, because you have that extra attenuation from the bodies. You don't have to worry about it hearing every single client. You don't have the side lobes that are going to be hearing it in the adjacent section. So it is an issue. It can be mitigated depending on which antennas you're using, but it is something to consider in your environment. Were there any other questions on the underseat before we move on for the Q&A stuff?
Yeah,
That was a
Connor,
good
I'd like to
answer.
ask one that was asked. A question was asked: Will the underseat option not increase the quantity of APs that you need to use to cover the whole stadium? Can you address that?
So it depends again on what you're trying to do, and we'll kind of get into this a little bit later, whether you're going for capacity or whether you're designing for coverage. If you're designing for capacity, a lot of times you're going to have to increase that anyway, and using the underseat enclosures can help you achieve that if you have full attendance. But if you're just going for pure coverage, then yes, an overhead design a lot of times is much more beneficial, because you can use a wider pattern antenna to be able to cover a single section of 100 people or even more, if you're not worried about every single client associating at one time and trying to go on and update their scores. So it depends on what you're designing for. So you may have to increase your overall AP density, but that may be something that you actually want in these scenarios.
Okay, I've had a private message asking about a very interesting question. So we are reducing the cell sizes when
Yes.
we put the APs under the seats, and then we put our big butts on top of these APs, which is great for reducing the coverage from the APs in the stadium. How about the clients operating on the same channels? Clients, you don't sit on the client, so they will still contribute to the client in your CCI, right?
Correct. Yeah, and that's partially where we're getting into a set and go with. The client device is still going to cause the most noise in those environments. There's not really a way around that. You can't tell the people who are coming, the attendees, what they're going to do, but it's just something that you have to plan. Yeah, exactly.
Okay, perfect. Thank you very much.
Yeah. So now looking at the other methodologies available to us, overhead, as we kind of mentioned, is good if you're just doing general coverage deployments. It is also not dependent on the actual attendance for that coverage. So being overhead, you can have 100% attendance or 0% attendance, and your coverage is going to be relatively the same. It's not going to be affected by that. There's obviously going to be slight attenuation from the head to the mid torso for client devices, but it's overall going to be the same. These are great for indoor solutions. So if you're using that enclosed arena and you can mount to a superstructure that's going above your entire stadium, it's fantastic to be able to deploy on that. It's up and out of the way so that your aesthetics are much cleaner. So if it's a black antenna and a black AP, if you use a skin or some enclosure of some kind, it just disappears into that roof, and the actual attendees will never even see it. Because of that, though, it can be harder to maintain. So you're not going to be able to just walk over to it with a standard safety torque screw, open it up, and do any maintenance you need on the AP. You will have to go into a catwalk or get out a scissor lift. So that can be more challenging if you have to go in and deal with that. You also, in these environments, when you're in a enclosed arena specifically, we'll see a lot more reflectance, both from that superstructure that goes overhead, as well as there's typically a little bit more concrete in these areas. And depending on what type of concrete it is, if it's really old concrete pre-1970s, that's actually much more absorptive for RF than newer concrete. A lot of the newer concretes have a lot of metal flakes in them, and that can cause a lot of reflectance in your environment. So you kind of have to plan on, okay, is it enclosed? Is it open? When was the original stadium built? And knowing that, you can kind of determine, is overhead coverage a good solution for you? And going again to the design, it's very similar. We just have to kind of think of our reference points. Well, again, if you're using a symmetrical beam with antenna to cover a specific area or a section within that area, well, your best practice is to make it to where that symmetrical beam width is flat to the actual grade of the stadium. So you're matching the angle of the antenna to the angle of the stadium. And again, we can just think about that as, okay, well, I'll rotate my AP and antenna, or my plane of reference And now I just have a top-down design. So when I go into Ekahau, I can simply go in and do it straight down versus having any angles to associate. You can also very simply do this to find any heights you need. So if you're coming into a stadium and you're trying to design for it, you can go and say, okay, I'm looking to design for that center seat as my center of the cell. I know I'm 5 meters away from it. And if I look up, that's 8.6 meters. Well, then I can just say, okay, that's an easy 10 meters away there. So I know what the height is when I go into Ekahau for this actual design. A little bit of flashback to some high school trigonometry for everybody. But that being said, when you're going on site to do any of these deployments, your best friend will actually be a laser rangefinder. So if y'all don't have one of these and you do a lot of large public venue, I recommend getting one. It's real simple to do, just stand where you are thinking about putting the antenna, point it up, say, okay, that's 8.6, point it at the seat, that's your 5 meters. It makes your life a lot more simpler on the design side afterwards. So looking at the overhead design, again, we can just come in and simply do a 0-degree tilt and plan for it to be able to do the simple cells of coverage. As you can see here, it's roughly the same size. So as we were talking about earlier is, am I going to have to increase my overall AP density because of the offset of the body attenuation? Well, again, if you're designing to keep it to where it's really tight cells of coverage, you don't have to. You can come in and you can still get that same AP density in those sections. And we'll actually pull it up here. So you can design for still, in this case, it was designed for 6 APs per section because that got into a certain range of AP to client ratio. I'm not going to give that away yet because we have a poll question on that later and I don't want to taint y'all's opinion on it. But you can come in and you can see, okay, well, I'm designing these specific cells of coverage. There's a little bit of secondary coverage going on. But I can easily get in and still do my really high density deployments. Now, that being said, maybe you don't want to have it to where it is that high density deployments. Maybe you are just designing for coverage only. Well, in that case, you can come in and just use a single antenna and you can cover the entire section by itself. You don't have to worry about, okay, I need to get 6 really tight beam width antennas. Whereas like these are our 20 dBi or 20 by 20 degree antennas. Which is a match to like the Cisco 9104 stadium antenna to get these really nice tight cells of coverage. That is good for when you're doing high density. Yeah.
Connor, since we're talking about the antennas and you've got the Cisco APs there as an example, Donald put in the Q&A that he's using your antenna 2456 81010 with the 8 NP, which he believes is meant to be with the 9167E access point, and he's asking, are they labeled 1 to 8 connectors to connect to the 9167E labeled?
So for that antenna specifically, so that's a fully tri-band antenna. That one is dual polarized, so the antenna elements do alternate between horizontal, vertical, 1, 2, 3, 4, and so forth. So it is designed to be used with the 9167E. It was one of the primary flagship antennas we had for it. But that being said, it doesn't necessarily matter which of those elements you are connecting. It's best practice to split it up correctly on the individual radio chains. So I think, I'm trying to remember, I think it's a 4x4 for 2, 4, and 5 for one of them, and then a 2x2 for 5 and 6, and then 2 scanning for the 9167E. So you may want to keep it to where you have a even amount of horizontal and vertically polarized elements in that case. But it doesn't matter as far as the actual propagation. Each of those elements is fully tri-band. It meets the gain spec of 8, 10, 10 dBi. So that's easier to deploy in that case for that.
Perfect. Thank you very much, Connor.
Yeah, so again, it just really depends on designing for coverage or capacity on your overhead. And going into it, you can use the overhead deployments outdoors because you don't have that physical superstructure. You're not going to be able to achieve the density as much as you would for enclosed deployment. So if you're just looking for pure coverage, you can definitely do outdoor with an overhead deployment. And this one specifically here, we did a great job with the Arista team and Bollock Solutions for Georgia Tech. We did this for them and they were super happy with it, let us use their name. So we have a couple of different use cases where they're letting us use their stuff, which we'll get into later. Another one with Arista and Bullock was for in-market arena, which was what we were looking at previously, which is a hockey rink. Similar idea, trying to do that just coverage dependent deployment. So they're using one antenna with a 60 by 110 degree beam width to be able to cover individual sections within this environment. And again, this is more of an enclosed arena design versus the open air solutions. And a big question that we have that we've touched on a few times here now, so I'm interested to see where the actual audience lands is. In your environment, are you really designing for coverage or are you designing for capacity? Or is it both?
Mac, do an impression of some elevator music whilst everyone's voting.
Elevator music,
Yeah,
like melodic house music.
yeah.
Oh, yeah.
Really?
Yeah, I was waiting for you. I thought you could do a good impression of it whilst we're waiting for everyone to finish voting.
I'm not sure it's a good idea.
Oh, okay.
Might
Fair
get
enough.
copyright struck. That good.
There we go.
I'll leave it at that.
Nah, that is plenty good enough. Thank you, Stu. We've had lots of people vote now, so I'll end the poll and share the results. So what do you think about that, Connor?
Yeah, so both. So that's definitely obviously a main concern is being able to get that capacity and coverage at the same time. Typically, if you're going to have to lean one way or the other, you're going to lean towards that capacity because you're just going to increase your overall AP density. But yeah, that is interesting that everyone's always wanting both.
Awesome.
And then finally for stadiums and arenas, we have a handrail solution. Handrail design was really big a few years back. It has kind of been phased out in favor of doing under seat for outdoor or overhead for enclosed arenas. It's still a viable solution, but it has drawbacks from kind of both the overhead and the under seat. That being is that your actual coverage is going to be dependent on your overall attendance. So it's only going to go so far into the section if you have 100% attendance, and if it's down to 50, it's going to penetrate a lot farther, and that may not be what you designed for. So it has that same drawback as the underseat did. It does have the benefit of being much more low profile because it is just blended in into the handrail. A lot of times you can do it to where it actually matches the section number. You can skin it to where this says section 101 and section 102 on the other side. So aesthetically it blends in. It's very easy to do any maintenance on. But similar to the underseat again, you run into the issue of every handrail is slightly different. There's not one universal handrail manufacturer out there that's being deployed throughout all these stadiums. So you have to slightly tweak how it's actually being mounted in most cases to ensure a snug fit. But the biggest problem on why people have moved away from it is mostly the ADA or the EDA, if you're in Europe, design concerns. So that's American Disability Act. It has to have a certain spacing between anything you put on the handrail and that top handrail to get around. Typically it's 6 inches. So for those reasons, a lot of people would just try to avoid doing that and swapping over now to the newer methodologies.
Could there possibly be one other potential reason why people are moving away from this solution? Which Mac, you marked this question as you was going to answer it live. Sorry.
Yep. So we have a question from Juan asking about the vandalization of these mounts. Is that a problem? Is that a real problem? Is it really easy?
I would say no more than it would be for the underseats. It's still very accessible to the public. I mean, if it's an underseat enclosure, I mean, anybody can go up there and jump on it and kick on it. And the same thing, if it's on a handrail, it's easily accessible. Anybody can come up and try to kick it and punch it. In our experience, well, at least with how our system is mounted, I can't talk for others. It hasn't been an issue. They're rugged enough that it's not going to be broken off. The actual handrail and the physical enclosure element to it isn't going to be damaged either from any beatings that I could take from the public. But it could be a problem if it's a lower quality one. If it's not installed properly, you can only do so much if the actual installers go in and they only put one screw on it. So yes, it could be an issue, but from what we have seen, it has not been a large issue.
Cool. Thanks.
And then the only real, we've done a few deployments with the handrail enclosures. The biggest one was for the Milwaukee Bucks. They were very happy with it. We actually did do a mix kind of with them. For some sections, we used the handrail enclosure. And for some, we used enclosures above the section that had the section number. And within inside that, you had the 3802 rather, with the RPTNC and the Dart. And one of the radios was covering the actual section, and the other radio was covering back onto the concourse area. So where that point of sale is, where people traverse to be able to get to their section, it was being dual use for both of those. So that's a really good use case of being able to use one of those dual radio antennas, dual 5 gigahertz antennas, to be able to cover multiple areas with 2 antennas. And kind of going on to that for the concourse areas and the point of sale areas, for a lot of people nowadays, this is one of the more pressing concerns. Everybody wants to be able to make sure they have coverage to be able to get people to go and buy hot dogs and buy burgers and buy merch at the shops around the concourse area. So you really have to design these to be very optimal. And the problem for these areas is that you'll see really high peak traffic at very specific times. The majority of the time, it's going to be very low. People are going to be watching whatever event is going on. But at halftime, at the end of quarters, at the beginning and the end of the games, these areas have really high density, and you always have to plan for that worst case scenario when 60% of the actual stadium attendance is just in that concourse area. And this has become a much more pressing concern in the past few years as digital wallets have become more prevalent. A lot of places are now accepting Apple Pay and Google Pay. So you need that coverage for attendees to actually go in and just be able to tap their phones onto those POS. So that has become a big concern lately. And in these areas, it's usually a higher aesthetic requirement than within the bowl itself. So when you're looking at these areas, you'll either have the higher end areas where it's the VIP or luxury lounge. And even just in the standard areas, a lot of people don't want to be able to see that. The architects who are designing these don't want to see anything. So within that, you can kind of just say, okay, well, let's skin an enclosure. So in this case, this has a AP on the left and an antenna on the right, same here, that's covering the VIP section of the Milwaukee Bucks arena. And we match the brick walling and the stone walling here to have these seamlessly blend in. So that was a more high-end solution. But even in just a simple use case of, hey, I don't want to see a white AP, as most APs are, on the ceiling or on the wall within the general concourse. In that case, you can just use a slip cover. So that slip cover there is just a solid black. It easily mounts onto with Velcro strips to any AP. Don't have to worry about painting it. It doesn't void the warranty. And it makes the AP, for all intents and purposes, disappear to the average consumer. So these are big solutions that can help you design in those concourse areas a lot easier, to where you're not having to use really specific or weird mounting positions that the architect allows. A lot of times in these areas, though, you do have these larger support columns. So if you are able to, instead of blending it in at eye level, you can get it up 25 feet and away from the prying eyes of the public, and use a directional antenna then to actually get your zones of coverage in those areas. And with that, you can actually do a wider beam width antenna typically to be able to cover a larger area than the average internal Omni would be able to cover.
Hey, Connor, just before you move on to the next slide there, you can see that you've got one of your NEMA enclosures there.
Yes.
So that's where there's an access point inside of that, and that box is protecting it from the elements and the weather. We actually had a question come into the Q&A from Osama. He was saying that when he's used enclosures before to protect access points, they found it particularly difficult to get in and check the access points for maintenance, and asking if there's any more like enhancements to these types of enclosures. And I'm going to speak on your behalf here, Connor, because I've used tons of Axeltech's NEMA enclosures for deployments. Even recently, we've had some going on that we've been helping out with. And the maintenance or on-site team needed to go and check to see if the access point was okay. And inside of these types of enclosures that you can see on the screen right now, it was still super easily accessible, even for someone to just quickly go up there and get into the box. So it kept it completely safe from the elements. And if you need to access it for maintenance or swap out or anything like that, with the Axeltech's enclosures, it's really easy to do.
Yeah, and to your point, you can see here, right here, just has simple latches. So all this is 4x for the specific enclosure, completely sealed, IP66. It's still easy to maintain, and you can also have
Yeah.
locked variants for if it's in public.
Yeah, the other thing I just want to mention as well, because you can't see it because it's on to the side. I know you do some of the NEMA enclosures where the front of the enclosure is actually clear, because what he was saying is like sometimes it's hard, like they want to go and try and blink the LED of the access point to locate an access point or see if it's still online. With your types of enclosures, the front, like the part of it is clear, so you would be able to see if the AP has got the LED on, if you need to go and blink it as well. So then you have options like that to be able to see. I know there's members of the Axel Text team in the chat. I can see them popping up. Perhaps they can make themselves useful and just grab one of these, the Axel Text NEMA enclosure examples I'm talking about, and put it in the chat so then people can go and see it for themselves.
Yeah, that's a great call out. Yeah, so that's a very good use case for if it's mounted up at that 20 feet and you don't want to bring in a scissor lift, just use the clear door enclosure and easily visible.
I thought it'd be good to put Matt Wedham to some proper work as well whilst he's on here.
I think that'd be the first time he did some proper work. Yeah, that'd be good for us.
Since we're talking about NEMA enclosures, we had a nice question about using them in a warehouse environment. Would you guys ever put the antenna into the enclosure in a warehouse?
So in a standard warehouse, you typically don't need that, but we do a lot of warehousing where it's a harsher environment, whether that be there's a little bit of manufacturing in there, and or it's a freezer environment. We do a lot of freezer environments within warehousing towards still plus 100 square foot warehouse that is completely frozen down to negative 20 degrees. And in those environments, we do use a lot of enclosures with either an antenna inside of it or mounted to the door, but that protects the AP. There's a little heater in there. So it depends on the environment. Standard warehouse, probably not. More harsh environments, yes, we do a lot.
Perfect. Thank you.
And then going back to just the Concourse design, just quick overview of you being able to come in and easily say, okay, well, this is a more aesthetically high requirement area because this is where people are eating, and maybe a VIP area. You can still just use a standard internal AP mounted to the wall. I know mounting an AP to the wall is not the greatest option. It's not what it's designed for. But if you need a really low profile and just using a slip cover, that can get you most of the way there. Or you can use that larger variant to blend in and use a directional antenna that's more designed for that environment. And then just the open areas. So you can use a wider beam width, 60 by 110 in this case, antenna to be able to cover the longer lengths of the concourse area. And that would be like the mount and enclosure we saw here on the previous slide. You'd be using that more on the exterior areas that are covering those longer corridors. And then in the individual point of sale areas and the VIP areas, you can use some of those aesthetically pleasing covers or enclosures. But for all these, for stadiums, the biggest advice I can give to you is do surveys. So every stadium is going to be different. Again, like we mentioned, the physical material is built out of, whether it's old concrete, new concrete, how the structure is designed with all the metal. It's going to be different every single time. You can do rough designs, but going in, surveying the existing network, or going in post-deployment if it's a new build and actually surveying it to see what's going on in your environment, and then going back into your design and making those adjustments. That's a necessity. You can't really get around that with these deployments for large public venues and stadiums specifically. So I always recommend go in and make sure that you're actually checking how your network is performing in real time. So as far as stadiums and arenas, that's kind of the high level best practices, and depending on what design methodology you want to use. One of the other main areas that we see for large public venues are convention centers. So we kind of mentioned this earlier. A lot of us are going over to HPE Tech Jam. We have Cisco Live coming up here in the US, as well as Discovery coming up. So these events get thousands of people coming to them. And in some cases, it's a very large area like Cisco Live, but you're still getting 10,000 attendance. And in other areas, it's a very small area, but real high density of where these actual attendees are going to be at. So that comes with a different set of challenges than you see in a stadium environment or an arena environment. Within those stadium arena environments, while you do have some mobility of the client, they may be walking around the concourse a lot of times. In a convention center, it's almost always mobile. So people are going to be walking around everywhere. You can't really design for them to be in one specific spot. So you really have to focus on that coverage requirement a lot more. And where it's getting everywhere versus stadium, you have these individual sections and zones that people are going to be at. It's still that same high density, and a lot of times in these environments, the aesthetic requirement is still very high, whether it be because the event hosting you says we don't want your stuff in our environment, or if you want to put it in our environment because we actually own the building, we don't want to see it. So that's typically an issue. And then you a lot of times will have a higher average use than you did in the stadium or arena, just because you're not going to have these individual times of, oh, it's halftime, everybody's going onto the phone at that time. But as a whole, it's going to be a higher average use because it's just going to be scattered out within the convention center where people are just on their phones or checking emails. The other issue that we see a lot of times within a convention center specifically is rogue APs. So rogue APs are hard to deal with, but a lot of times guys will come and they have their own booth, and maybe they have some weird proprietary network or weird setup where they need to set up a little hotspot, and they just pop it up without thinking about it. And then that's your problem as the actual event hoster to go in and try to manage that or isolate that rogue AP. So we have to really kind of deal with that more on the convention center side than we do for the stadium and arena.
And someone mentioned there's like, how do you deal with rogue APs? And that example out of Cisco Live that you have there, I just think back to our good friends that we saw when we was at Cisco Live Amsterdam, and obviously they're trying to provide Wi-Fi to such a high density conference, which is going to be like, almost a little bit be like being judged on the performance of the Wi-Fi network there. So they really want to have a high performing Wi-Fi network, and having so many clients, so many access points, external antennas, they really want to minimize the amount of channel interference. They do a great job with the design at Cisco Live, but what can really cause havoc, especially if you've got lots of different booths, like you got the Ekahau booth, Axeltex booth, and however many other 100 booths there. If we all came in and turned on our own personal hotspots or brought in our own personal Wi-Fi devices, the performance of the Wi-Fi network would be so seriously degraded. And what we saw at Cisco Live Amsterdam is the TAC team, the on-site team from Cisco, is they're walking around with Ekahau, and they are live looking for any potential rogue devices. So they are basically playing a bit of like a hunting game to go and locate. They're constantly surveying the conference. They're using like the analyzer application to go and find the source of the most strongest signal coming from these rogue APs. And to be honest, in these environments, they go find them and they remove them. You're not allowed to bring in your own devices, and because they know it's going to cause a big problem to the Wi-Fi network. So in that example, if you've got rogue devices causing issues on your Wi-Fi network, you use Ekahau, go survey, use analyzer, go track it down, find it, remove it, and then keep your network performing, especially for such a high profile event like Cisco Live, or if you're trying to do stadium Wi-Fi or big, large public venues, you need to have a clean RF environment as possible.
Yeah, that's a fantastic use for the spectrum analyzer component beyond just survey. So thanks for pointing that out, Matt. So looking at convention center specifically here for the more open areas, there's usually a variance between there's an open floor and then sometimes there's little lecture halls. For this specific deployment, we went with a design that was able to actually house 4 APs and 4 antennas to a single node. So you can kind of see it here on the chandelier variant. You'll have the 4 AP stacked. This one actually had a switch on it as well. So we were able to run fiber down to the switch and then power the fiber and power down to the switch and then power the APs up. And have that dedicated per section. So this is a very niche use case, but it can save your butt in a very high density deployment where you're trying to get as much capacity as you can in a very small area. And kind of looking at that, so this is what it would look like within Ekahau. You just stack the APs on top of each other. For all intents and purposes, within it, they're literally on top of each other. And because of that, you can come in and design for a 60 by 60 meter, which is like 300 feet by 300 feet area with 36 APs. So you can get really, really high AP density with a small area and still have small channel interference even on 2.4. So that's where we see a benefit using these kind of, we call them chandelier designs, is being able to get that real high density within a very small area. And talking about some client capacity needs. So within a high density environment, what are you aiming for your client to AP ratio? We kind of touched on this previously. I'm curious to see where everyone lands. I hear very different things depending on what the end user is.
From the audience. Exactly this.
Yeah. because we have our best practices depending on your need, but I'm always curious to see where a lot of our customers and end users end up.
Yeah, I'm a big fan of the one client per AP model,
Yeah.
especially if you work in sales. Okay, we'll give it a couple more seconds because there's a lot of members of the audience participating in this poll question. I can see that there's still some answers rolling in and kind of slowing down a little bit now. If only we had someone like Stu to make some more elevator background music whilst the poll question was going.
Dum 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 da dum 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 dum.
Okay. Let me
I'm trying to think of I'm trying to think of an 80s theme song that somebody would guess, right? Like
Like
if you
your
guys can
favorite.
think of that one.
Dum 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 dum.
Yeah, throw the Star
Oh
Wars
yes,
Imperial
I
March
could
on
see
there.
that.
Yeah.
Yes, that's right. Well, I was trying to play Airwolf, but that's
well, people got it,
yes.
Stu. People have said put it in the chat and in the Q&A.
Yeah,
Correct.
yes. Good.
People can
Nice.
do in the chat
Excellent.
Q&A.
Yeah, we're gonna get copy struck for that one, Stu. It was that close.
Yeah.
Yeah, so this is interesting results here. So 48% of y'all said 31 to 50 clients per AP. That's about where we recommend. So in a really high density deployment like a stadium or some of these convention centers, our typical goal is to hit around 50 clients per AP. Depending on the individual user, it may be a little bit lower. You may try to get to 40, or you may be a little bit higher. You may be at 75 if you know it's not going to be a super high amount of traffic going through that. But yeah, so it seems like the general public is around the same kind of thinking, hitting that 50 client to AP ratio. So going back to convention centers, less in the open areas, but more like a keynote area. So within a keynote area, it is a little bit more similar to then looking at a stadium deployment where you do now have very dedicated areas of, there's going to be 200 people in this one seated section, and the next session there's going to be another 200. So with that, you can design a little more streamlined. So in this case here, we just mounted AP adjacent to an antenna across this I-beam going down the entire length of the keynote. And because of that, we got really easily isolated cells of coverage using a really high directional antenna. This one in this case was a 45 by 45 degree antenna. So you can get these nice isolated shells, not a lot of overlap, just enough with the adjacent one to get a little bit of secondary coverage. But within that, you can go in after the fact. And in this case, we did a survey during the actual event when there was a bunch of attendance there. There's 10,000 attendees at this specific event. And using the Psychic V2, we actually went through it and scanned it all. And it matched very closely to what our predictive said. At this event, though, we actually were one of the first ones to use 6 gigahertz. This was over in London, so we were able to use our antennas in the Juniper Mist 45E to utilize both 6 gigahertz and 5 gigahertz. And within that environment, we had a very similar coverage to what we'd expect between 5 and 6 gigahertz. They were nearly identical. There was a few minor fluctuations, but it was very interesting to see that in these actual deployments that we were getting the same coverage overall. At that event, we also had some areas that needed temporary coverage. So whereas some parts of it, we were allowed to go in and mount physically to the superstructures in the ceiling, and some areas either because it was this kind of grid network, or they just didn't want anything to be mounted to their structures because they were worried about damaging it, or they just didn't want it up there. Well, in those scenarios, you may need a temporary style deployment. So in that case, it may not be the most aesthetically pleasing, but you can come in with a structure like a Wi-Fi stand or a Hive radar that lets you easily mount a AP and antenna to do more dense cells of coverage than just the regular internal AP, but they're very easy to go out and deploy and very easy to take down too. So temporary coverage is a big thing for a lot of these convention centers because they may not let you use their proprietary Wi-Fi, but they may also not let you actually deploy anything within their environment. So that's an option to keep in mind. It may not be the best option, but given the scenario, it could be a viable option for you.
Connor, quick question from since you had up there before around that deployment that was done around the 6 gigahertz.
Mm.
We have a question from Larry in the chat about the impact of designing for Wi-Fi 6E deployments, considering that clients are restricted to be 6 dBs lower than the access points. Are we finding ourselves deploy more access points? What transmit power would we use, or what would we recommend?
Yeah, so in this environment, so I think for this one, we had 10% of the actual attendees had 60 capable devices when we were going through and looking at everything. So it seemed like for the most part, we did have to increase the transmit power to keep the cell sizes the same. It wasn't the offset of the 6 dB like it is on the client side. I think it was only 2 or 3 dB. But there was a need to give a little bit of an offset to be able to make it to where the actual client device could talk back in the same zones of coverage as you would expect on 5 gigahertz. Yeah.
So a little bit of extra juice on 6 gigahertz helped
Just
those
a little,
clients.
not a whole lot, but a little bit. Yeah.
Okay, good to know.
And the last thing for convention centers is that it's not always just indoors. They a lot of times have either outdoor plazas, eating areas, the initial walkway up to them. These areas can be harder to deploy depending on if they let you mount anything to the side of the building. So in these environments, we oftentimes recommend using a baller solution. So these can be anywhere from 24 inches up to 48 inches in height. And that can allow you to mount AP, outdoor AP, or an AP antenna, just depending on what your needs are. So that's a viable solution for any walking paths or outdoor areas that you could possibly encounter for a convention center. In the last area that we personally really consider a LPV environment or auditoriums. There's a couple different styles of auditoriums, whether that be a lecture hall or a concert or event hall. We're specifically going to be looking at the lecture hall side of it, more on the higher education. Hopefully that's because in the concert halls, you're not using your phone. Hopefully you're watching the event or you're listening to the music. You're not sitting there on your phone or any other device you're bringing with you. So it's the same idea of design, but we're going to be looking at the lecture hall side of it a little bit more. So within that, for the auditorium lecture halls, if you look at the anatomy of it, it's very similar to a section of stadium seating. So you still have the sloped grade of the seating. It's a high density environment. You can get up to 100 people per section. But you have a little bit more of a challenge now because you know that the actual end users are going to be using their devices. For higher ed specifically, they're going to be using their laptops. They may be on their phones. The guy in the back of the class may be on YouTube, ignoring the professor. So it really is going to be a much more challenging environment to design for because you know that utilization is going to be much higher. It still can have the aesthetic requirements. Not every university does. Some of them just say, we just need good Wi-Fi in here. You can do whatever you need, put it in. But some of the older universities, like in the Northeast, those are almost historical sites at this point. So they really like to mask anything that goes onto their walls. They'd like to keep that aesthetic high. These students are paying a lot of tuition to be at a high-end university. So it can become a requirement of, hey, we need this to be blended into our environment. It needs to disappear. But the biggest benefit that we have really of a auditorium design versus a stadium design is there's a lot more mounting options now. So there's a ceiling that you can mount either in or above. You have the walls that you can mount onto now. So with that, you get a lot more options than you did for the standard stadium seating that we were previously looking at. But you still have all the same design methodologies plus now the wall. So you could use handrail. I didn't include that here because most auditoriums nowadays seem like they don't have a whole lot of handrails. But you can still use underseat. We have a couple of universities up in the Northeast that do underseat deployments for their lecture halls. Overhead is pretty typical. And then what we see a lot is the wall deployment, whether that be on the side walls or the front and back walls. That's pretty typical nowadays to be able to get cells of coverage within the actual auditorium itself. So high level here, just real quick, if you had a section here pulled up, you can do overhead coverage, kind of how we were discussing earlier. This can either be flush to the ceiling, or it can be on a grid structure, just depending on how the actual building is designed. But we can also pull over here and look at the environment. And these ones here, as we can see, are designed to be top down, straight. This is roughly a 60 by 60 degree antenna. So you're creating these nice isolated cells of coverage. In the back area, we just have a 60 by 110 antenna to be able to do wider cells of coverage just for this open area as students walk in. Nothing's grown back to that. There's very minimal overlap. But we can also then come in and design for these side cell coverages very easily. By just coming in and putting them on the wall now. Giving them a little bit of a down tilt. And then you can still create these little zones of coverage for the walls. So it really depends on what you're looking for and what the design requirements are that you're getting from the university. But it can be done either way. So that's an extra possibility within these auditorium designs. So what are the key takeaways that we've discussed here between both stadium and arena, convention center, and auditorium, all these large public venues? What is a consistent kind of note across them all? So we talked about coverage and capacity. It's always really, what are you designing for? That's going to depend on the actual end user. It's going to be different use case to use case, but you have to determine that off the bat. The aesthetics requirements are always going to be high. Again, get your architect involved as early as possible. That'll save your life when you're actually going to deploy these. And then what are you actually going to be doing with this network? What are your client devices? What is expected utilization? Determining that really determines kind of that first coverage or capacity need. Do you own the space? Are you doing temporary deployments? Is it a permanent structure? And then what is that permanent structure? Is it the older concrete, the newer concrete? Do you have a superstructure? What are the physical seatings? So across all these are kind of the main questions that as you're going down your checklist, you need to ask yourself before you move in to doing the survey, doing your design, and going out there and deploying a successful large public venue network. That's some links to my social media. If y'all want to connect, I'm always happy to answer any questions online, or if you want to hop on a call, I'm always happy to help.
Thank you, Connor. I'll take over the share quickly just to put up our next webinar, but we'll stay on and we've got some great questions in the Q&A, so we will answer quite a few questions, I am sure. But I just want to mention to everybody, make sure you sign up to our next webinar. Mac and we're going to be spending the whole webinar just doing live demos. We've got some really interesting project files that we're going to be analyzing, talking about best practices, what can go wrong if you skip some of the elements of best practices, some interesting validation surveys we've had to cover for some challenges that people are having with the Wi-Fi network, should we just say?
We'll be talking how to fix these things, okay? What to look for and how to fix it. So we'll not only just point fingers, what's wrong, but you will see like best practices and how we work typically with difficult projects. Yeah.
Okay, Mac, I think you've got a few questions and Dale marked as to answer live. So do you want to just chime in?
Are you still there? Or is Stu gone? I wonder, because we have a great question about any tips for design for cruise ships.
Cruise ship terminals. But yeah, I saw that too.
You guys.
Yeah, great audio quality, Steve.
I think, yeah. Oh, is it better now, or is it not so good?
Better, yeah.
Yes. You know what? I think we're gonna get up.
I'm just going to answer for Stu. Basically, he was on a very large cruise recently, checking out the Wi-Fi for that cruise ship. So we might have some information coming about that and some tips on cruise ships soon. But since he's struggling with audio, we don't want to put our audience through the pain of listening to that. So why don't we move on to another question? And Dale, I see you've got one marked here that you'd like to ask live.
Yeah, so one of the questions asked is more so around the stadium design and such, but what are you using to represent the attenuation associated with people sitting in seats, specifically around those designs where you have the antennas mounted under the seat or the handrail mounted antennas?
Yeah, and here, let me pull up the design again.
Let me stop sharing because they won't see
it back from you.
Yeah, go ahead, mate.
Yeah, so as a baseline, I'll typically stick with the human crowd attenuation field. So I find that that's fairly close, especially as a baseline. You can come into the attenuation fields and select human crowd. That's really where it comes into go out there and physically do your survey. It's unfortunate to say if you do a human crowd over in Europe versus a human crowd over in America, you probably got a little bit more attenuation over in America. So I would definitely recommend doing it. But as a baseline, this attenuation field is a good starting point.
Thank you.
Um,
Another question asked. Oh,
sorry, go ahead. Go ahead, Dale. I'll ask my one after you. Go ahead. You go ahead, mate.
Another question asked. This one was by Larry, but is there any impact or adjacent channel interference to crisscrossing antenna beams?
Yeah, so if you're crisscrossing the antenna beams, it will cause interference, primarily from the same channel or the adjacent channel, like you mentioned. That's more on the design side. You typically wouldn't do that for design. I'd be curious to see where they're going to deploy that to where that's being an issue. But that can be easily overcome with a good design.
Didn't I see as well, like if you're gonna, let's say you've got one axis or you got 4 access points in your chandelier antenna option, and you got obviously like 4 antennas coming from that bracket. If you're using, let's say, like 5 gigahertz or 6 gigahertz, I've seen there's been like a recommendation that you have at least 100 megahertz of channel spacing between channels on 5 gigahertz.
So that I haven't really checked into or tried. The physical spacing between that is over 3 wavelengths. So that isolation kind of helps, just that physical separation. So I think for a couple of those, we have them to where they were adjacent channels or just one separated or like one in between.
Yeah,
we
or
haven't experienced any issues, but
it might
it's probably
that
practices too.
That might be where I'm getting that from, actually. It might be when you've got access points that can flip one of their radios to be a flexible radio, and you've got like dual 6 gigahertz or dual 5 gigahertz when they're very close to each other. Their
On the
recommendation
same
might
AP, if you have it to where it's that
Yeah.
may be more of a benefit there. Yeah.
that might be where I was getting that from. But yeah, definitely great question there. There's another question that came in around for designing for high density and the best approach for when it comes to channel configuration. Is the recommendation 20 megahertz wide? Is that the same for 6 gigahertz? Or what would be your thoughts here, Connor?
Yeah, in high density, 20 megahertz is usually your best bet. It's a lot more channels, one that you get to use without having to worry about channel utilization as much. And you're also going to hear a lot less noise in the environment using those smaller channels. So yeah, 20 megahertz is recommended.
I would just quickly add to it. So the higher the density of your network, the usage of your Wi-Fi network, the most destructive the CCI is going to be.
Right,
so in a very empty warehouse, 25 CCI might not be a problem, but in a very dense and heavily utilized office, 5 CCI might be a massive issue, right? Depending on what the clients do and how many we have. I have another great question about the RRM from Nick. So he asked about the underseat design, but I think it's translatable to like all the designs that we've discussed. The question is it a good idea to use RRM to control TX power of APs so that adjustments can be made for the number of the butts in the environment? What are your thoughts on that?
So that depends. We've talked about this for a couple different deployments. It really is recommended to keep that static. Now, if you know it's going to be a lower attendance event, yes, you may drop the transmit power, but the RRM, you're either going to have it to where it's adjusting too quickly and it's making too many changes and it's going to get stuck in a death loop, or it's not enough to really even make a difference. If it's every hour, you're not going to notice a change in your environment that much, and it's going to be changing so significantly between that hour that it's really better to keep it a static transmit level. So it's hard to use RRM for the transmit powers in
I would add more to the question. Do you ever feel it's beneficial for any environment to drop the EIRP of the radio, the access point with the antenna, below what the clients are capable of?
I can't think of any environment where that'd be super beneficial.
Me neither.
Yeah.
Yeah, so that's a good tip. Like, if don't drop the TX power too much, because you are not fixing CCI. The clients will still induce the CCI in the environment. What you are hurting now is the data rates.
Correct.
Okay. Do we have any more good questions?
I think Dale has one more marked live that we can take.
Yeah, absolutely. So this question comes from Nick, and he asks, does the number of clients per AP differ depending on the design approach? With underseat designs, clients are closer to the AP, so data rates may be higher than with overhead APs. Or is the attenuation caused by human bodies? a really big factor in reducing data rates, which will reduce throughput and therefore capacity.
Yeah, so you kind of answered the question there at the end. So that is the correct assumption, that extra attenuation of the bodies basically drops the data rate as much as you would as being farther away with a more directional AP. So it will roughly be the same in that scenario.
Okay, great. Well, I think then we'll probably wrap up the end of the webinar today. So thank you so much for joining us, Connor, and everybody else on the webinar today. Do make sure you sign up to the next upcoming Ekahau webinars. I can't say too much, but we've got some pretty huge news coming soon over the next few webinars. So you're going to want to make sure you're signed up so you don't miss hearing this first. So yeah, get yourself signed up nice and early for our next upcoming webinars. And huge thank you to the Ekahau team, Connor, and everybody else on the webinar today.
And a massive thank you to the audience, guys. Without
Yeah.
you, there is no Ekahau webinar. So we appreciate you a lot. And thank you very much, Connor, for donating your time.
Yeah, thank y'all for
Yeah.
having me on. It was great to be on again.
Always a pleasure.
Never a chore. See you in Vienna.
Yes,
See
sir.
ya.
Have a good day.
Bye,
Ciao.
everybody.